This is Lab 9 for Physics 2211. Our main problem is to examine the motion of a spring mass system in which the mass swings in an arc while oscillating on the spring. In our main results, we find that the swing of the mass works independently of the oscillation of the spring. We make these findings using both the momentum principle and the energy principle. The motion we analyze is a mass oscillating on a spring and moving in both the x and y direction. Using Tracker, I gathered my experimental data. If you look at the model, you will see the experimental data represented by the blue ball and the model data represented by the orange ball. As you can see, the model closely follows the experimental data, both in the display and on the graph. The movement in the x direction is represented by the blue and the yellow line, and the movement in the y direction is represented by the red and the green. We can also use the graph to determine the period of the x and y oscillations. If we measure the distance between the crests, we can find the period. Using this method, I found the period to be 1.65 seconds in the x direction and 1.52 seconds in the y direction. As you can see, the two differ. This is because the motion in the x and y directions are independent of each other. When we add the spring to the system, we can see the potential energy of the spring represented by the red line. The green line represents the kinetic energy, and the blue line represents the gravitational potential energy. The total energy is represented by the yellow line and remains constant throughout the model. Because our delta E is 0, we know that no work was done on the system. Therefore, the energy principle is satisfied. If we change the origin to the point of equilibrium, you can see the physics of the system will not change. The only thing that is affected is the gravitational potential energy. Because the mass is higher relative to the origin, the gravitational potential energy is higher, which in turn makes the total energy higher. The total energy, however, remains constant. Therefore, the energy principle is upheld.